You've been thrown into the year 1500, Renaissance Italy. Leonardo da Vinci is alive. Michelangelo is painting the Sistine Chapel. Art, science, discovery everywhere. Beautiful. On the third day, you realize you need to capture a moment, preserve it, prove something happened. You need a photograph. Before you build anything, let's understand what a photograph actually is. Because most people use cameras every day and have no idea what's happening inside. A photograph is not magic. It's chemistry and light working together. Here's what happens. Light bounces off an object, a face, a building, a landscape. That reflected light carries information about the object's shape and color. The light travels through space until it hits a surface. If that surface is light sensitive, meaning it changes chemically when light hits it, the information gets recorded. The pattern of light and dark becomes permanent. That permanent pattern is a photograph. Two things you need: a way to focus the light into an image, and a surface that reacts to light but then stops reacting so the image doesn't disappear. Renaissance Italy has one of these. They're missing the other. And the missing piece is so close they could stumble into it by accident. Let's start with focusing light. This part they already have. Camera obscura, Latin for dark room. The principle was understood in ancient times. Chinese philosopher Mo Tzu described it in the 5th century BC. Arab scientist Ibn al-Haytham explained the optics in the 11th century. And by the Renaissance, camera obscura was a well-known tool used by artists. Here's how it works. You take a completely dark room, just one tiny hole in one wall. Light from outside passes through that hole. Because light travels in straight lines, the light coming from the top of an object outside goes through the hole and hits the bottom of the opposite wall. Light from the bottom of the object hits the top of the wall. The image projects upside down. Why upside down? Because light travels in straight lines and doesn't bend unless something forces it to. The rays cross at the pinhole. Top becomes bottom. Left becomes right. Perfect geometry. Now make the room smaller, a box instead of a room. Make the hole smaller and add a lens to focus the light more sharply. You have a portable camera obscura. Artists in the Renaissance used these to trace accurate perspective drawings. They'd set up the box, let the image project onto a piece of paper or ground glass at the back, and trace the outlines. Leonardo da Vinci described camera obscura in his notebooks, explained the optics, drew diagrams, used it for studying perspective and light. He understood exactly how it worked. So the optics are solved. You can project a perfect image onto a surface. The problem, the image disappears the moment you remove the surface or open the box. It's not permanent. It's not a photograph. It's just projected light. You need chemistry. Here's what you need: a substance that changes color when light hits it, and critically, a way to stop that change once the image is captured. Otherwise, the substance keeps reacting to light and eventually turns completely dark, erasing the image. Let's talk about silver nitrate, because this is the chemical that made photography possible, and it was known in the Renaissance. Silver nitrate is a compound of silver, nitrogen, and oxygen. When you dissolve silver in nitric acid, you get silver nitrate. Alchemists in the Middle Ages knew how to make it. They called it lunar caustic because silver was associated with the moon. They used it for cauterizing wounds, removing warts, and various medical treatments. Here's the critical property. Silver nitrate is sensitive to light. Specifically, when light hits it, it breaks down into metallic silver, which is dark gray or black. The brighter the light, the faster the reaction. In darkness, nothing happens. This was observed as early as the 13th century. Alchemists noticed that silver nitrate solutions darkened when left in sunlight. They had no idea why. They just knew it happened. By the Renaissance, this property was well documented. If you coat paper with silver nitrate solution and let it dry, you have light-sensitive paper. Put an object on the paper, a leaf, a piece of lace, anything opaque. Leave it in sunlight. The areas exposed to light darken. The areas covered by the object stay light. Remove the object, you have a silhouette image, A photogram. Artists and experimenters in the 16th and 17th centuries definitely made these. They called them sun prints. It was a curiosity, a party trick, not taken seriously as anything more. But here's the devastating problem. The image keeps darkening. The paper is still coated with silver nitrate. The areas that were protected from light are still light sensitive. The moment you look at your beautiful silhouette in daylight, those light areas start darkening too. Within minutes, the entire paper turns dark gray. The image disappears. You're left with a uniformly dark sheet. This is why photography didn't exist until the 19th century. Not because the optics were missing. Camera obscura existed for centuries. Not because light-sensitive materials were missing. Silver compounds were known. The missing piece was fixation, stopping the chemical reaction so the image becomes permanent. The first person to solve this was Joseph Nicephore Niepce in 1826. He used a different light-sensitive substance, bitumen of Judea, a type of asphalt that hardens when exposed to light. He coated a pewter plate with it, exposed it in a camera obscura for 8 hours, then washed away the unhardened bitumen with lavender oil. What remained was the world's first permanent photograph. But even Niepce's method wasn't perfect. 8 hours of exposure, blurry, barely visible. It took Louis Daguerre another decade to develop a practical process in 1839 using silver iodide-coated copper plates and mercury vapor to develop the image. The critical breakthrough Daguerre made. He discovered that sodium thiosulfate dissolves unexposed silver salts without affecting the developed silver image. This chemical became known as fixer. It removes the remaining light-sensitive material, leaving only the permanent image. Sodium thiosulfate, also called hypo, the chemical that makes photography possible. And here's the thing that will keep you awake at night. Sodium thiosulfate occurs naturally. It forms in volcanic hot springs. It can be synthesized from sulfur and sodium carbonate, both available in the Renaissance. It was known to alchemists under various names. They just never thought to use it to stop silver nitrate from darkening. Everything necessary existed in the year 1500. Every single component. So here's how you make a photograph in Renaissance Italy. First, the camera. You build a camera obscura, a wooden box, dark inside, with a convex lens mounted at the front to focus the image. The back of the box has a removable panel where you'll place your light-sensitive surface. This is standard Renaissance craftsmanship. Any lens grinder and woodworker can make this. Second, the light-sensitive surface. You take paper, or better yet, a thin copper plate for sharper images, and coat it with silver nitrate solution. Let it dry in darkness. Now you have a surface that will darken when exposed to light. Third, exposure. You mount the coated surface at the back of your camera obscura. Point the camera at your subject, a person, a building, whatever you want to photograph. Open the shutter. Light enters through the lens, projects an upside-down image onto your silver nitrate-coated surface. The bright areas of the image cause more darkening. The dark areas cause less. Over several minutes to an hour, depending on sunlight, a faint image forms. Fourth, and this is the part they were missing, fixation. You remove the exposed surface in darkness and immediately immerse it in a solution of sodium thiosulfate dissolved in water. This dissolves and washes away all the remaining unreacted silver nitrate. What's left behind is only the darkened metallic silver in the pattern of the image. The image is now permanent. You can look at it in daylight. It won't change, it won't fade, it's fixed. You just created a photograph. In the year 1500, 326 years before Niepce, 339 years before Daguerre. Here's the historical moment that should haunt you. Leonardo da Vinci understood camera obscura perfectly. He studied optics, light, perspective, anatomy, chemistry. He experimented with everything. His notebooks are filled with observations about how light behaves, how images form, how substances react to environmental conditions. He knew about silver compounds. He knew they darkened in light. He had access to alchemical knowledge about sulfur and sodium compounds. He had every single piece of the puzzle within arm's reach. He just never put them together in that specific way. If Leonardo, or any Renaissance experimenter, had thought to test different chemical baths on darkened silver nitrate paper to see which one stopped the darkening, they would have discovered fixation. They would have invented photography 3 centuries early. The printing press had just been invented 50 years earlier. Imagine if photography had arrived at the same time. Imagine illustrated books with actual photographs in the 1500s. Imagine accurate portraits of every Renaissance figure. Imagine scientific documentation with photographic evidence.
Excited, imagine how differently history would have unfolded.
The knowledge was there. The materials were there. The curiosity was there. The only missing ingredient was one specific experiment that nobody thought to try. So here's what you do. You find Leonardo. You show him your camera obscura. He already has one. He'll immediately understand. You show him paper coated with silver nitrate darkening in sunlight. He's seen this before. It's a known curiosity. Then you show him the key. You take the darkened paper and dip it in your sodium thiosulfate solution. The unexposed areas, still sensitive, still ready to darken, wash away. The image remains, permanently, in full light. Leonardo stares at the fixed image in sunlight. It's not disappearing. It's not changing. It's permanent. He understands immediately what this means. His mind is already racing through applications. Portraits that capture exact likeness, scientific drawings made directly from nature, architectural documentation, astronomical observations, military reconnaissance. He asks how you knew to use that particular solution. You tell him you simply tried different compounds until one worked. He nods. He's done the same thing thousands of times in his own experiments. Sometimes the breakthrough is just testing one more thing. That night, he fills pages in his notebook with observations, improvements, ideas, mirror configurations to flip the image right side up, different silver compounds to test for sensitivity, refinements to the camera design, ways to mass-produce the chemicals. Within a year, photographs are being made in Florence. Artists use them as references for paintings, capturing exact poses and lighting. Scientists photograph specimens, celestial events, anatomical dissections. Wealthy patrons commission portrait photographs. The technology spreads. Printing presses start including photographs in books. By 1550, illustrated encyclopedias contain actual photographic plates.
Historical events are documented photographically as they happen.
3 centuries later, when Niepce and Daguerre are working on their own photographic processes in France, they're not inventing photography. They're just catching up to what Italy has been doing since the Renaissance. You didn't invent it. You just remembered one specific chemical they forgot to try.